The last section of the chapter that we are going to go over is section 6, Systems of Second-Degree Equations. 3 methods to note here. First of all, in order to solve equations simultaneously, or where you find their intersection points, you can use method 1 using algebra. That means substitution or elimination. You can use the second method of using a graphing calculator, which I'm going to have to show you in class because it's kind of hard to show on a video. And the third method is to use a combination of both. So here's one of 2 examples I'm going to go over in this video. It says to solve x squared plus y squared equals 20, which you can see is a circle, and x minus 5 squared plus y minus 5 squared equals 10, which is another circle. I copied a picture of what we have in our book, what these 2 circles look like. And I'll explain the blue line here in a second, the x plus y equals 6 line. So we need to figure out where these circles intersect. Circles can intersect in 0, 1, or 2 places. And this diagram shows us that we're looking for 2 solutions. Okay, so here we go. I feel the best way is to use elimination. In order to do that, I'm going to have to expand x minus 5 squared and y minus 5 squared. So I'll go ahead and do that here. If I square x minus 5 squared, I'll have x squared minus 10x plus 25. Expanding y minus 5 squared, I'll have y squared minus 10y plus 25, and that's set equal to 10. What I'm going to do is get all of my constant terms over to the right side. So I'll have an x squared plus y squared. I'll put my other 2 terms here, minus 10x minus 10y. And since I'll be subtracting 2 25s, or 50, from both sides, I'll get a negative 40 over on the right side. So that's my second circle equation, is right here, just revised. Okay, so what I'm going to do then is eliminate. I will subtract the x squared plus y squared equals 20, the first circle equation, from the second. Now remember, if I'm subtracting, go ahead and change the sign on all of your terms so that I have an x squared minus x squared is nothing, y squared minus y squared is nothing. I have a negative 10x minus 10y, nothing is being subtracted from them. And then my constants on the right side, I'll get a negative 60. Everything here is divisible by a negative 10, so I'll go ahead and do that. So I have x plus y equals 6. Okay? That actually gives us this line, this linear equation right here. What that linear equation does is it's telling you that there's a line that will go through the 2 points of intersection where those circles are going through. It's kind of like a tangent line. Okay, so what do we do with that? Well, from here we can either solve for x or for y. Let's go ahead and solve for y. So y is also equal to negative x plus 6. So it's this linear equation just rewritten. So if y is equal to negative x plus 6, I'm going to plug that negative x plus 6 in everywhere I see y. I need to pick one of these equations. I like to use the first circle equation because I don't have to expand anything or FOIL anything out. So I'll rewrite everything in terms of x. So I have x squared plus y squared. Y is now negative x plus 6. Remember to square it. And that's set equal to 20. So I have to expand this one part out. So I have a negative, or actually it's a positive x squared minus 12x plus 36 equals 20 when I expand that. And adding like terms, I have 2x squared minus 12x. I'll kick 20 over here, subtract 20 from both sides, so that is plus 16 equal to 0. Everything's divisible by 2, so now this is x squared minus 6x plus 8 equals 0. I can factor that into an x minus 4 and an x minus 2, because 4 times 2 will give me the 8. Added together, I'll get the negative 6. Okay, so that would make sense because our x coordinates of our points of intersection up here on our graph would be 4 comma something and 2 comma something. So x is 4 and x is 2. Okay, what happens if x is 2? Plug it into one of your equations. You can even try it in this linear equation. So 2 plus y is equal to 6. So if x is 2, y has to be 4. And then if x is 4, 4 plus what is 6? Y has to be 2. So your answers are 2 comma 4 and 4 comma 2. Those are your points of intersection solved algebraically. So we need to solve these two equations simultaneously. Okay, we can also use elimination. So if we have a 2x squared plus y squared equal 4, and then I will subtract this, I have an x squared minus 2y squared equals 12. Nothing is going to eliminate as it is, so what I need to do is multiply or divide one or both of these equations by a number. What I'll do then is eliminate the y. So I'm going to change this into, I'll multiply it by 2, and I'm going to change it into 4x squared plus 2y squared equals 8. And this one's going to stay the same as x squared minus 2y squared equals 12. Now there isn't a rule saying you have to add or subtract. You just need to do one or the other. I'm going to add because that would eliminate the 2y squareds. So if I add, I'm going to get a 5x squared, and then that is equal to 20. So I'll divide both sides by 5. So I have x squared is equal to 4. Well, the square root of 4 is positive or negative 2. So there's two possibilities here because for our answer for x, we got positive or negative 2 for our answer. We're going to plug in each one of those into one of my original equations and figure this out. I'll just choose the first one here. So if I take 2 times x squared, let's say if x is positive 2, that's going to give me 4, plus y squared is equal to 4. Well, that's 8 plus y squared equals 4. I'm going to go ahead and subtract 8 from both sides. So y squared is equal to negative 4. And if you take the square root of it, we're getting an imaginary number because this is a negative. So this is going to be I, or 2I. Square root of 4 is 2. The negative is telling me it's going to be an I. Well, we can't graph imaginary numbers, so anything using x equals 2 isn't going to work. So that leaves us with x equals negative 2. Let's try that. So if I have 2, I'm going to plug in negative 2 for x and square it. That's 4 again. Plus y squared equals 4. Looks like I have the same thing. I'm still going to get y equals 2i. So if you come up with something goofy like this, there is no solution. These two graphs do not intersect each other. And if you were to graph this on a graphing calculator or go ahead and sketch out the graphs, you would see that we actually have an ellipse at the origin, and then we'd have hyperbolas going this way so that these two graphs do not intersect at all. So if you run into imaginary numbers or something goofy like that, it doesn't mean you always have to find a solution. I'll give you your assignment when you get to class.